Question 4 asks which of the following could be the center of a circle with tangent lines y equals 3 and x equals -2, and it gives us 4 possible points. Let's start by thinking about the circle. So here I have my circle, and it has 2 tangent lines. So it could be here and here. And this one here is when x is -2, and the green one is y equals 3. In order for these to be tangent to the circle, that means if here I have my center and I have some radius r, those are both a distance r away from that center. That was just some arbitrary circle. There are actually infinitely many circles I could draw. There's another one that goes like this, and it's really large. And here, of course, you have a center, and it also has some other radius r. The point is, no matter where your circle is, it could even be up here, it would have to be the same distance from one as it is to the other. It could also be over here, and on the bottom left as well. So what this really tells us is that there are many possibilities for where the center could be. In fact, it could be along the line connecting these, as in this line, or it could be along the other line. These lines have to have a slope of 1 and -1, and that's because you always go up and over the same amount. So one of these 4 points that they ask us could be the center must be on one of these lines. So this line, or the 2 of these lines have an intersection. That intersection is at -2, 3. It's where the 2 lines meet, the 2 tangent lines. So I can use point slope form for regular lines to figure this out more. It tells me that y minus a y value, which in this case is 3, is equal to the slope, which is 1 or -1, in this case I'll go with 1, times x minus the x value. Well, that's x minus -2. And of course there's also that case where the slope is negative, in which case I have negative x minus a -2, or negative x minus 2. So one of these 4 points must satisfy one of these equations. I'll call that the red one, and this one can be the green one. So let's start with the red one. In the case of 0, 0, well, that clearly won't work. You'll have -3 equals 2, and -3 is not equal to 2. So that doesn't work with the red equation. For B, I have 2, 1. So if x is equal to 2, then I have a 4 on the right, and if y is equal to 1, I have a -2 on the left. And -2 is not equal to 4, so that doesn't work. Now if I try saying x is -3, -3 plus 2 is -1. And if y is 1, 1 minus 3 is -2. -2 is not equal to -1, so that does not work with the red equation. Now let's look at D. For D, x is equal to 2. 2 plus 2 is 4, and y is equal to -1. -1 minus 3 is -4. -4 is not +4, so that does not work with the red equation. We still have one more equation to check with, so let's try the green equation now. If I try again using 0, 0, I get something that obviously doesn't work. So no. And then 2, 1, well, that gives me -4 has to be equal to -2. That's not true. -3, 1 means that 1 would have to be equal to -2. That's not true. And now in the case of 2, -1, well, if x is 2, I have -2 minus 2, or -4. And on the right, I have negative 1 minus 3, which is negative 4. So yay! The answer is D.